Good day, guys. In this video, we will be talking about nonlinear programming. So what is nonlinear programming? These are problems that fit the general linear programming format but contain nonlinear functions. Ibig sabihin, they have square roots or raised to the power of 2 or raised to the power of 3. Yun yung mga nonlinear functions. Normally, their graph is not a straight line just like those sa mga linear functions. Solution methods are more complex than linear programming methods. And in fact, determining an optimal solution is often difficult, if not impossible. But for this video, we will be using Solver using Microsoft Excel. So the first topic is nonlinear profit analysis. So let's take, for example, our break-even analysis before where we crafted a profit function Z. Sa profit function na ginawa natin last time, we have said that the profit is equal to the volume times the price minus fixed cost minus volume times the variable cost. Pero in the past, we have assumed that the volume is independent of the price. Meaning, kahit nagbago yung price, hindi mag-change ang volume. So kahit tumaas ang price, kahit bumaba yung price, the demand or the volume for the product remains the same. But if you think about it, it would be more realistic for the demand to vary as price increased or decreased. Tama naman, di ba? Kasi, for example, if tumaas yung price, then lesser people will buy your product because medyo mas mahal na yung product mo. And so on. Or pag binaba mo yung price, baka mas marami or mas lumaki pa yung demand for your product. So for example, let's add a volume-price relationship. For example, ito yung volume-price relationship. Volume is equal to 1,500 minus 24.6 times the price. If we graph this formula sa Excel, ganito yung magiging itsura ng graph niya. So, the slope is negative 24.6 and this is the line. This shows that habang tumataas yung price from 0 hanggang tumataas na value, the volume or the demand for the product decreases. So that means as price increases, demand decreases. Pag 0 yung price, syempre maraming bibili. Your demand is 1.5. Pero pag tumaas ng tumaas yung price na yan, then yung volume for your product also decreases up to a particular price level, 60.98. That will result in no sales volume. So kung mapapansin nyo, pag naging 60.98 na yung inyong price, wala nang magdedemand ng product mo. What more pa pag mas mataas pa sa 60.98. So, if we insert our new relationship for volume, yun na nga yung volume is equals to 1,500 minus 24.6 times price into our original profit equation, yung Z, and substituting fixed cost to 10,000 and variable cost of $8, then our new formula for Z will be something like this. If you observe, it's 1,696.8p or the price minus 24.6p squared minus 22,000. So mayroon ng squared sa ating profit function. And that is not an example of a linear function. Nagiging non-linear function na to. At kapag graph natin yung formula na yan, ganito yung magiging itsura ng graph. Para siyang curved line. No? So para siyang curve. Now, if we look at the curve, this point here is the maximum point and this is the optimal solution. So, The slope of a curve at any point is equal to the derivative of the curve's function. Derivative is discussed in calculus. And if the derivative or the slope of a curve is equal to 0, then that is its highest point. So para siyang peak, no? Pag sa bundok siya, ito yung pinaka-peak. So this is the maximum point. Now, if we use calculus to compute for the optimal solution for our example, then using calculus, the optimal price is 34.49. So ito, this is the optimal price. If your price is 34.49, this is where your demand is optimal, which is at 651.6 pairs of jeans, and your profit is at maximum at 7,259.45. Now, you might ask a question, Sir, what if hindi namin alam yung calculus? Or what if we do not know how to arrive or generate the derivative of a curve? So ang good news dyan is meron tayong solver to solve this example. So we will try to solve that same problem, but this time using MS Excel. So if we open Excel, we can input here sa topmost portion, single nonlinear function. So first thing that we have to input is the demand or the volume. Okay. So we input lahat ng ating mga important things. So second is the price. And take note, sa ating profit function, yung price yung ating part ng formula. That means this price, this will be our decision variable. So si Excel ang magsasabi ngayon kung ano yung magiging price na optimal yung solution. So tulad ng ginagawa natin, if it is the decision variable, we highlight it or we fill the cell with color yellow. Tapos we also encode the fixed cost, which is 10,000 as of the moment. We will also input the demand. Since the volume is a formula, then we input that formula. The formula is equal 1,500 minus 24.6 times the price. Okay. And then we will also input the variable cost, which is at 8. And then we will also input the profit, which is, in this case, this is our objective function because we want to maximize profit. The formula for profit is equals the price, or B5, times the demand or the volume minus the fixed cost, B6, minus the variable cost, B7, times the demand or the volume, B4, and click enter. So since, ignore nyo lang muna yung mga lumalabas na number. Since this is our profit, then, or the objective function, we fill the cell with color blue and put a tick box around it. Now, if you already inputted this, it's very simple. You just go to data and then click solver. Your set objective is the profit, which is B8, and then you choose maximize by changing variable cells yung price, which is B5. Wala muna tayong constraint since wala namang constraint na sinabi, so this should be left blank. And then choose in the select a solving method, you click this dialog box. Before we were choosing simplex, but this time we choose GRG nonlinear. And then click solve. Click OK. So if you observe, guys, the demand or the optimal price is 34. So we just round this off. We go to home and then we just click this comma so that it will round off the decimal places. Yeah. So the price at the optimal price is 34.49, and at 34.49 ang magiging demand or ang volume is 651.6, and ang maximum profit ay 7,259.45. Okay? So these are the same answers that we got when we use calculus. So para hindi na tayo gumamit ng calculus, it's easier to solve this problem using solver. Okay? So that is how you use nonlinear programming in a single nonlinear function. Easy pa siya kasi wala pa siyang constraint. So what if meron na siyang constraint? So we will discuss constraint optimization. If you remember sa Harry Pottery Company natin, it is very easy to solve using a simplex method because yung profit niya fixed amount. Hindi siya nag-change, no? Or hindi siya function, hindi rin siya formula itself. So what if naging nonlinear yung Harry Pottery Company? Example, this will be our objective function. Maximize profit, which is equal to 4 minus 0.1x sub 1, or x1, di ba, is yung bowls. So ang profit for bowls is formula na rin. Times x1, or the number of bowls, plus 5 minus 0.2 x2, or the number of mugs, times x2. Subject to the constraint, x1 plus 2x2 should be equal to 40. This is the labor constraint, if you remember. Pero this time, we will use the constraint equal to signify na dapat gamitin niya talaga yung buong 40 hours. Where x1 is the number of bowls produced, x2 is the number of mugs produced, 4 minus 0.1 x1 is the profit per bowl. So if you remember before, ang profit per bowl, 40. Pero ngayon, ang profit niya, meron na siyang fixed component or fixed cost at meron na rin siyang component for variable cost. No? So this is the new profit. That will make it nonlinear. And then 5 minus 0.2 x2 is the profit per mug. So how do we solve this in Excel? Okay, so we go to Excel again. If you're following, you just create a new sheet for Excel. Okay, and then we will encode Harry Pottery nonlinear. So on row 4, we will encode the products. So we have bowls. So for column B, we have bowls. And for column C, we have mugs. So if you remember, yung sa baba nilang dalawa, we should use it as our decision variable. So we fill it with yellow and put a border. And then yung profit natin, profit, will be in a form of a formula. So for bowl, ang profit is equal 4 minus 0.1 times the number of balls, which is B5. Enter. Para naman sa mugs, ang ating formula ay 5 minus 0.2 times the number of mugs, which is C5. Enter. And then sa side, we put a formula for the total profit, which is the sum product of array 1, B5C5, and array 2, B6C6. Enter. Since this is our objective function, we fill it with color blue and then put a border. And then on row 9, we put the constraint. Since isa lang naman yung constraint natin, labor lang. For bowls, gagamit daw siya ng 1 hour. And for mugs, gagamit daw siya ng 2 hours. And then, yung usage natin will be the total or the sum product of the number of bowls and mugs, which is B5 and C5, and the constraint, which is B9 to C9. And then, yung constraint natin is equal sign. And our available hours is 40 hours. So, ganito lang siya. If you were able to follow and input this, we are now ready to click solver. So, go to data and then click solver. Our objective is D6, which is maximize profit. So, choose max by changing variable cells, yung naka-yellow, which is B5 and C5. And then, subject to the constraint, so we add the constraint. Our cell reference is the usage. And then choose the drop-down, choose equal, and then the constraint is the available, or yung F9. And then click OK. So, isa lang yung constraint natin as of the moment. Don't forget, choose GRG NonLinear, and then click Solve. So, okay. And then use the rounding off method. Go to home, and then click this comma here. So if you observe, ito po ang ating optimal solution. The optimal solution for bowl is 18.33. Sa mugs naman, 10.83. If you observe, the maximum profit will be at 70.42. All the labor hours 40 is used up. Okay? So this is how you solve a nonlinear model with one constraint. Before we go to the next, let's first try to see ano ang magiging itsura ng sensitivity analysis. So you go to data again and then click solver. And then when you click solve, you choose sensitivity. So when you choose sensitivity, may lalabas na sensitivity report 1. When we open that, I want you to focus on this one, no? Yung log range multiplier. So if mapapansin nyo, dyan sa constraint, the final value is 40 hours. Pero meron siyang log range multiplier of 0.33. Ang Lagrange multiplier is para siyang shadow price. It is like a shadow price, meaning for every increase in labor of 1 hour, madadagdagan ng 0.33 natin sa profit. Okay? So for every hour of addition, then there will be an additional profit of 0.33. Okay? So yun yung usage ng ating sensitivity report. Now, you might ask the question, Sir, what if there are a lot of constraints? So what if maraming constraint? So the next thing that we will be talking about is multiple constraints. So let's take, for example, this company, Western Clothing Company. So this is the objective function for Western Clothing Company. So meron siyang profit, maximized profit, which is price or P1 minus 12 times X1 plus P2 minus 9 times X2. So ano ba yan? Subject to these constraints. 2x1 plus 2.7x2 is less than or equal to 6,000. This is the cloth or the materials constraint. 3.6x1 plus 2.9x2 is less than or equal to 8,500. This is the cutting constraint. While the third is 7.2x1 plus 8.5x2 is less than or equal to 15,000. This is the sewing constraint. So cloth, cutting, and sewing. Where X1 or the demand for the product is equal to 1,500 minus 24.6 P1. So if you will observe guys, dependent po ang demand or ang volume sa price. That means, ang independent variable or ang ultimate na hahanapin natin is yung price. Kasi yung volume, dependent lang sa kanya. X2 or the demand for the second type of product, which is straight leg jeans, yung first product, X1, designer jeans. X2 is equals to 2,700 minus 63.8 P2. P1 is the price of the designer jeans and P2 is the price of straight jeans. So how we will solve this sa Excel? So we go to Excel. On the same Excel file, we just add a worksheet. So we add a worksheet and then we put there, say Western Clothing Company. So on row number 4, we put the products. There are two types of products. We have designer and we have the straight leg. So first, we will input the demand, pero hindi po ito yung variable cells. Kasi ang variable cells is the price, no? And the profit. So the price is the variable cell kasi sa kanya dependent ang demand. So we fill that with yellow and then put a border. So just leave it blank kasi siya ang variable cells. The demand lalagay natin yung formula for the designer jeans. The demand is equal to 1,500 minus 24.6 times the price of the designer jeans, B6. Ang straight leg naman, that would be 2,700 rather, minus 63.8 times the price of straight leg, which is C6. Ang profit naman, for the designer, the profit is the price minus 12. So, for our profit, for designer jeans, the profit is the price, which is B6 minus 12. For the straight leg, the profit is equal to the price C6 minus 9. Okay, and then we create a formula here for total profit. The total profit is equal to sum product of the demand P5 to C5 and the profit B7 to C7. Kasi profit times demand is equal to the total profit. Then we will now, in row 9, we will encode the constraints. So we have 3 constraints. Tulad ng sinabi ko sa inyo kanina, there is cloth, there is cutting, and there is sewing. So, first, for the cloth, the formula is, ang designer daw, it will use up to, and for straight leg, it will use up 2.7. For cutting, for designer, it will use 3.6, siguro hours yan. And then for straight leg, 2.9. And then for sewing, the designer will use 7.2, while straight leg will use 8.5. Siguro hours din yan. So in this column D, we will type the usage. Since this is a sum product of the demand times this one, then we will just copy the formula we did for total profit. But remember, we should put a $sign first sa B5 and C5 para hindi siya mag-move. So $sign B, $sign 5. And then $sign C and $sign 5. For others, for other laptops, the shortcut is F5. You click enter. So pag naglagay na kayo ng $sign, you can just copy it and then paste it here. And then you just drag it pababa. No? And then, ang ating constraint ay, sabi kanina, it should be less than or equal to. And same lang silang lahat. Our available resource is for cloth, ang available lang natin ay 6,000. For cutting, it's 8,500. And for sewing, that's 15,000. So, if you were able to do all of this, we are now ready to click Solver. Let's go to Data, and then click Solver. So, ang ating objective is maximize profit. That's D7. Okay, and then choose maximize by changing variable cells yung naka-yellow, which is in this case, ang ating variable cell is the price. Kasi hindi pwede yung demand, again, kasi yung demand ay dependent sa price. And then we will add constraints. So add constraints. For the cell reference, ilagay natin yung usage. So since same lang naman silang less than or equal, so we can just do it as one. So sa cell reference, D10 to D12. And then the drop-down box, choose less than or equal. And then the constraint is yung available, F10 to F12. Since tatlo lang yung constraints at ginawa na natin siya as one, then you click OK. And then on the select a solving method, choose GRG nonlinear. And then click solve. So if you observe, okay, so i-round off lang natin. If you observe sa ating solution, our maximum profit is 32,459.23. Paano natin to ma-achieve kapag ang designer jeans ay priced at 36.49? Ang maximum demand kapag 36.49 yung price mo sa designer jeans, ang demand ay 602.4. Pag straight leg naman, ang optimal price is 25.66. At that price, ang demand ay magiging 1,062.90. So, this is our optimal solution. If we will check sa constraints, ang cloth hindi nagamit ang buong 6,000, 4,000 lang yung nagamit. For cutting, hindi rin nagamit yung 8,500, around 5,251 lang yung nagamit. And for sewing, the available 15,000 was not used up kasi ang ginamit lang ay 13,371. So, this is our solution for nonlinear programming models with multiple constraints. So, yun. So that would be all for this video lesson. Thank you very much for staying up to this point and for watching the entirety of the video. I hope na nakafollow kayo. If you have any questions, you can comment sa video na to or you can send a personal message sa akin sa aking social media accounts. So that would be all for today and I hope you enjoyed our lesson on nonlinear programming. See you in the next video. Thanks guys. Bye.